Okay, good morning, everyone. Today we're going to review the last four modules of this Engineering 7 class. The last four modules are probability, sorting and searching, time complexity, and also data structure. Okay, so before I start this this final review, I just want to quickly give you guys some general suggestions that you guys might want to follow during this last 2 or 3 days of final review. So since this is a MATLAB class, okay, so besides that you guys need to fully understand what is some basic concept and how those algorithms are working, please pay attention to how algorithm or some sort of idea could be implemented in MATLAB. For example, if an algorithm has a corresponding MATLAB function that will be able to fulfill this function, functionality, please pay attention to that. Be careful about what are the possible input and output of this function and what is the algorithm inside this function. Okay, so because in the exam you guys might have some kind of like code question. For example, they give you some code and ask you to write down probably what is the output and probably ask you to write down a few lines of code. So in that case, it will be very helpful if you guys have some knowledge about a specific MATLAB function that has that functionality, right? So this is the general suggestions I have. I'm not quite sure whether other GSIs or instructors have mentioned this before, but I think this will be very helpful for you guys to do the final review. So just type in help function name in MATLAB command window as often as you can and see how this function works. Okay, all right, and then I will go ahead and start from the probability. Okay, so I will just type in probability. Okay. Okay, so there are, but in general, there are just two parts in this probability module. The first part is just give you some basic concept of the statistics. Okay, basic statistics. Okay, so in this part, I think what is the most important one is you guys need to be familiar about several metrics that are frequently used in statistical field. For example, let me just type in this. Okay. For example, mode. Okay, mean, median, and variance or standard deviation. Okay, so let me just quickly go through everyone. The mode just corresponds to the most frequently occurring value in the sample data, right? So let me just type it in here. Okay, so for example, if you have some sample, like if you have 10 samples, where 8 of them are number 1, 2 of them are number 2, so the mode is definitely number 1, right? And the next one is mean. The mean gives you some idea about the average value of the data, right? So for example, if you have n samples, and the mean value will just be the summation of all the n numbers divided by n, right? And the median, it quantifies the value at the middle point of all the data. Okay, so that means if you, for example, if you have 11 data points, the median will just be the value of the number 6 data point in this all sample if the sample is in some ascending or descending order. Okay, and then what is the variance and standard deviation? So these two metrics gives you some idea about how spread those data are around the mean value. Okay, and you guys can review how this variance and standard deviation are actually calculated. So the variance is just calculated using the summation of each data point minus the summation of the distance between each data point and the mean value squared. Okay, so and the standard deviation is just like some sort of the square root of this variance, but you guys need to be a little bit careful whether it is divided by n or divided by n minus 1. Okay, so there are different ways of define the standard deviation. I think there's a homework that corresponds to this question. You guys may want to take a look. Okay, and the second part is after we are done with some basic concepts of the statistics, I want to review the second part. It is the some specific distribution. So most importantly, it is the normal distribution. And also we talk about this concept of confidence interval. Okay, you guys want to, I think you guys should be pretty familiar about those two concepts at this point. So first, in order to define some distribution, okay, so a very common way of doing that is to define it using the probability density function. Okay, so probability density function. Okay, so okay, let me just interrupt here. What is a normal distribution? So a normal distribution is defined using this probability density function. I think it is in the discussion note. Let me. I think it is in the lecture note. Let me point this to you guys. Hold on for a second. Okay, it is on the page 9 of the probability slides. Okay, let me just write this down for you guys so that you can take a look. Okay, of normal distribution. This is on page 9. Okay, of the slides. Okay, so normal distribution is where there is an even probability of any specific location. No, I think that is uniform distribution, Michael. That is not normal distribution. Yeah, I think normal distribution is something like the curve is something like in the mean value, the probability density is like pretty high, and once it goes further away from the mean value, the probability becomes smaller and smaller. Okay, so it's like a bell curve. Okay, so yeah, this is something like that. So and be careful, like this probability density function of the normal distribution is actually defined using as mean and standard deviation. Okay, so in the middle of the bell curve, it is the mean. Christina, you're correct. Yes. So let me see if it is. I think it is not quite easy to type in this probability density function in this discussion note, because we have some sort of mathematical equations there. So, but if you guys take a look at the page 9 of the probability slides, the probability density function of a normal distribution equals to 1 divided by sigma square root of 2 pi times exponential of x minus mu square divided by 2 sigma square. Okay, so this mu is the mean of this normal distribution, and the sigma is the standard deviation, and the sigma square, you can treat it as like the variance of this distribution. Okay, so should we know that equation by heart? If you could remember that, that would be great. Yes, Christina. I'm not quite sure whether in this MATLAB class, whether you guys should remember this, but definitely it is quite helpful if you take this from a statistical point of view. So this is normal distribution is probably the most important distribution you guys might need to use in your future classes. So I think it would be great if you guys can remember that. Okay, and later on, after we're done with this normal distribution, we also talk a little bit about the uniform distribution. Okay, so I think the uniform distribution is given on page 12 of this discussion of this lecture note. Okay, and let me just write down this note as well of PDF of unit. Oh, you guys might not need to know the probability density function, but you should have some idea about get some idea about the uniform distribution. Okay, and that is actually on page 12 of the slides. Okay, what should expect to code these? We should expect to code this command, correct? Yes, I think so. Mark, I will like also briefly review the MATLAB functions that you guys might want to remember for each module. Okay, I will do that after I'm done with each module. But you're correct. You guys need to have some idea about what is the function that like I mentioned, what is the function that implements the specific algorithm or specific probability distribution. Okay, and so let's back on here. So for the second part of this probability module, you guys want to have some idea about what is the probability density function, what is normal distribution, what is uniform distribution, right? And then a very important part of this module is this central limit theorem, okay? The central limit theorem. So what the central limit theorem tells you, let me just point out this to you. It is on page 13 of the discussion of the lecture note, okay? So I don't think you guys need to have a really rigorous mathematical proof or like very specific like mathematical expression about what this central limit theorem is, but what you guys want to have is some kind of understanding about what this is, okay? So if you take a look at page 13, this central limit theorem really tells you that once you have like very large data points, okay, for example, like this x1 through xn, when this n becomes really large, the distribution, okay, of the mean value of all these n data points, okay, tends to be Gaussian, okay, and its mean tends to the mean of the total population, okay. So basically, what the central limit theorem is telling you some distribution about the mean value of those samples from a large population, okay. So that's basically what this central limit theorem tells you. I think if you guys want to have some further understanding about this central limit theorem, you can definitely take a look at, for example, the Wikipedia page or some external resource for this for the theorem. But I think within the scope of this course, what you guys really need to know is that the mean of this large population tends to be Gaussian, okay, and its mean tends to the mean of the total population. So that's what is really important for you guys to understand. I see there is some sort of quick question on page 13 of the central limit theorem page, and I think you guys might want to have a quick and reasonable explanation about how the central limit theorem explains the normal distribution of the grades in the course examination. Okay, so if you guys can explain how this one works, probably that means it is fine for you guys to pass this central limit theorem part. Okay, but anyhow, I will write down this as one part of the things you guys need to review, and then I will go to the next definition. It is the confidence interval. Okay, so Mark, so we should this. In the final exam, I'm not quite sure whether you guys need to write some sort of like commentary, as you said, but I think something that, yeah, about CLT, what I mean is like if you can have a reasonable explanation about this question, that means you guys probably have a good understanding of the central limit theorem. That's what I said. but it is not necessarily that you guys need to write a lot of stuff in the final exam. Okay, and then let's just go to the confidence interval. Okay, the confidence interval is essentially telling you that some sort of, as this name suggests, like how confident you think your value should be in a specific interval given a specific probability distribution. Okay, so for example, if let me just so this concept of confidence interval is shown on page 16 of this probability lecture notes. Okay, page 16. Okay, so you guys should have a good explanation of the confidence interval using normal distribution. Okay, so what I mean is, like, for a normal distribution, okay, you guys should know, okay, so given a mean and the standard deviation of a normal distribution, how can I calculate this kind of confidence interval with 95% confidence interval? That means if I sample enough data from this distribution, 95% of this data will be located to this interval that I specified. Okay, so for a normal distribution, this 95% confidence interval is plus and minus 2 sigma. Okay, the sigma is the standard deviation. So for example, if my mean is 10 for a normal distribution and my sigma is 1, that means if I sample from this normal distribution, 95% of the data point will be located between 8 and 12. Okay, so that's what essentially this confidence interval tells you. Okay, so you guys might want to have some good understanding about what the confidence interval is. And if you want to learn more, you're definitely welcome to look at the Wikipedia page or some external resources. So in general, this Wikipedia page is a good way for you guys to do the final review, because it gives you some basic concepts of it gives you a little bit deeper concept, okay, of a definition or some specific functions or distributions, but it is not going too deep. Okay, so that's why, I mean, if you guys want to have a further studying, you can refer to the Wikipedia page of each concept you guys want to have. Okay, okay, so Mark, please type in which concept or functions or algorithms or distribution do you want to learn about, and I will be happy to post the Wikipedia page link in this discussion note. Okay, and while Mark is doing that, let me quickly review with you guys about the functions that you guys might want to use in the probability module. Okay, so first, several stuff is from the basic statistics. Okay, so from this point of view, you guys definitely want to have a good understanding about what is the mode, mean, median, SCD, and VAR. What are those functions in MATLAB? Let me type in here. Mode, mean, median, VAR, and SCD. Okay, so these are from basic statistics. And besides that, you guys want to have some idea about what is the function of PDF. Okay, what are the inputs of this PDF and what are the possible outputs. Okay, and very important one from this module is the two functions called RAND and RANDN. Okay, so please take a look at how these two functions work. What are the output of these two functions? And you guys might have some sort of good understanding about how can I possibly variate the output of this random and random n so that it will generate the random numbers with a larger or smaller scope. Okay, because this random actually will give you the value value from 0 to 1, but how can you enlarge that to 0 and 10? How can you make it smaller to 0 to 0.1? Okay, so that's probably something you guys want to have a good understanding about. Okay, and then besides that, there is also a function called error bar. Okay, so that is just nothing but a plotting function. Okay, I think that's less important, so I will not type in that name in this review notes. Okay. Okay, so okay, let me just quickly get those links for you guys. Normal distribution. I think this is the Wikipedia page of normal distribution is actually quite mature at this point because many people help contribute to revise this page. Let me just okay, let me just put it here. Okay, and well, you want to have standard deviation. What is confidence interval? Okay, I think for the standard deviation and variance, I think you guys don't need to look too much about the Wikipedia page because I think that might go too far away. And also for the confidence interval, I will put something here, but what you guys really need to know is how you want to have a good explanation of the confidence interval from a normal distribution. Okay, that's the most important part. Okay, and for standard deviation and variance itself, I think you can just review that using the lecture notes. As long as you understand what is the definition, you guys should be fine. Okay, and I think that's the end of the probability module. And the next one we're gonna review is this the sorting and searching module. Okay. So this module basically talk about what is the searching problem, sorting problem, and it briefly introduced several algorithms to do the sorting and the searching. Okay, so okay, so one thing in general that is very important is that the sorting and searching algorithm. Okay, when you guys want to make some sort of MATLAB function or MATLAB code, it always involves this kind of iteration or recursion. Okay, so I highly recommend you guys to review how to implement iterations and recursions in MATLAB. Okay, review this part. I think that will be very important for you guys to make some algorithms. For you to make some sorting and searching algorithms. Okay, that's something very general. Okay, so first part of this module is like we wanna have some basic idea about what is the sorting problem. Okay. Okay, the sorting problem is actually just like giving you some sort of random numbers, and you want to put this number in some predefined order. The two very commonly used is this ascending and descending order. Okay, and okay, so these are the two possible output format of a sorting problem. Okay, and then once we know what is a sorting problem, and then we go ahead with the sorting algorithm. Okay, so if you look at the sorting and searching slides, you can see that there are actually a lot of sorting algorithms being mentioned in the slides. Okay, I will just write down all of these. Okay, so the first one, I will do that according to what I think is the most important. Okay, so the first one is bubble sort. Okay, and then we talk about straight insertion. Okay, and then we talk about merge sort. And we also mentioned, for example, shells method, heap sort, and also this quick sort. Okay, so here is my understanding about what is in terms of the importance. I think bubble sort straight insertion and merge sort are probably the most important ones in the sorting algorithms, and I recommend you guys to pay more attention to these three. And for the shells method and heap sort, quick sort, you guys I don't think you don't even need to like look at that in very good details. Okay, so you may want to take a look at the Wikipedia page about what are these, but if you don't have enough time for your final review, you can just ignore these three. Okay, and I think for bubble sort, let me give you a Wikipedia page for you guys to take a look. The algorithm of bubble sort is also given in the lecture notes. Let me get this number for you. This bubble sort algorithms is given on page 7 of this lecture notes. Okay, let me just put it here. Page 7. Okay, and I'll also put a Wikipedia link here for you guys to take a look. Okay, so in general, this bubble sort is just like doing something like kind of quick, very straightforward. It just compared for example, it compares the first two numbers and switch the other if it doesn't meet our requirement. Okay, and then it goes to the second one, compare the second one, the third one, and it gives you the correct order between the newly ordered number two, the newly ordered second element, and the previously the third one. Okay, so essentially it first compare A1 and A2. Okay, and then switch the order. Then they compare the new A2 and the old A3, and do this all the way to like the new A minus 1 and the old AN. Okay, and after they are done with this whole round, it's do that with the second iteration. Okay, so in that way, it will be able to finish this kind of sorting. I find that there is a very nice animation in the Wikipedia page of this bubble sort. I think that's very straightforward for you guys to understand how this bubble sort is working. Okay, so let me just see. Okay, I think it's still here. Once you're at this page, you will see that there is a animation called an example of bubble sort right next to the performance analysis of this bubble sort page. Okay, so you guys want to take a look at this animation, and I think that will be very helpful. And also, you guys can take a look at page 8 through 23. Okay, example at page 8 to 23 of the lecture notes. Okay, so there is also an example in the lecture notes to get yourself familiar about what is a bubble sort. Okay, and then for the straight insertion, okay, so that one is actually given on page 9 and 10. Okay, so what this straight insertion gives you is like it's just like emulates the technique used by the card game players to sort their cards, basically. So let's say if you have given some sort of numbers that has already been sorted, okay, and what it did is for given a new number, okay, it would just look at, okay, what is the good place for me to put into the those already sorted numbers. For example, if I want to, if I already have that 1, 2, 3, okay, if I already give, if I already have this 1, 2, 4 being sorted, and now I get a new new card, number 3, I will just, okay, look at which is a good place to put. Definitely I should put between 2 and 4, okay? So that's the way for you to look at that, okay? So if you are giving a totally unsorted numbers, okay, so what you do is you first compare the first two numbers, and switch the place if necessary, and then you look at the third number, okay, and see what is the good place to put. You should put it before 1, between 1 and 2, or after 2. Okay, so once you're done with the first 3 and you pick up the fourth number and see what is the place I should put. I should put it before 1, between 1 and 2, between 2 and 3, between 3 and 4, or after 4. Something like that. And you repeat this whole process for all the numbers unsorted in your unsorted array. And that's how you do the straight insertion. Okay? And similarly, there is a Wikipedia page that corresponds to this straight insertion. Let me copy and paste the link here. Okay, and also there is also a very nice animation in this Wikipedia page telling you how the straight insertion is doing. And similarly, there is an example in the lecture notes from page 27 to 32. Okay, it is also an example exactly telling you how the straight insertion is doing. And then we have this merge sort. Okay, this merge sort it's just like one page in the slide. I think it's page 33. Okay, let me just put it here, page 33. Okay, and then I can also show you guys the corresponding Wikipedia page of this merge sort. Okay. Okay, there is no example given about the merge sort algorithm in the lecture notes, so I would say that probably this one is not as important as the first two, because the first two they give you a very nice example. But I think this merge sort is also very important, especially in the practical use. I think you guys also make some programs of this merge sort. Okay, and also on the Wikipedia page, there is a very nice merge sort animation, just the same like bubble sort and straight insertion. I think they have the same unsorted array. Okay, and when you check each page, they will do the sorting of this unsorted array using the 3 different algorithms. Okay, so you guys might want to take a look of these 3 animations for you guys to further fully understand what's going on in these 3 algorithms. Okay. One more thing before I end up is you guys want to have some sort of idea about the efficiency of those algorithms. Okay, so the most efficient one among these 3 is the merge sort. Okay, so it is more efficient than the bubble sort and the straight insertion. I think that's the only things you guys need to remember. Okay, and Mark, you have some question. Would we need to make a commentary on these, like commentary from CUM in Q3? I think so. You guys might want to have some sort of quick commentary. For example, if they give you, okay, a unsorted array, and they will probably ask you, okay, so what will be the output of this like bubble sort algorithm, straight insertion algorithms, and merge sort algorithms in each step of these algorithms? So that's why you need to have some idea about how this algorithm works in order to actually write down the algorithm for each, write down the output of each step. Okay, and then we want to go to the search part of this. Yeah, I don't think you guys have. Well, I don't think it will be very extensive or very intensive. Okay, so because like the thing is, like in the homework, they want, because you have more time and you really run the simulation, so that it will be easier for you guys to make some detailed commentary of algorithm or idea. But when you are in the exam, okay, what you have is really based on what you understand or what you remember. Okay, so I think the commentary will be really short, and it will be highly based on the like very basic concept. Okay, and then we start with the search part. Okay, so the search part, there are actually like two different kinds of problems that all correspond to this name of search. The first one is like giving you an sorted array, And how would you be able to find a specific number from this array? Okay, and the second problem is like giving you a sorted array. How could you find a interval that this new key number could be located? For example, if I get a key 9.5 and I give you a sorted array, and you want to give me two numbers which forms a interval that include this 9.5, and that's the second kind of problem of this search. Okay, I think in the slides, the search problem is defined in the second way. Okay, so you are basically trying to find an interval that includes the key values. Okay, and okay, so basically for this one, it's actually fairly clear. There are just basically two ways of doing the search. It's like linear search and binary search. Okay, so of course, you guys should know that the binary search is generally more efficient, and the linear search is more like brute force, I think. I would just make a commentary here more. Okay. For sure, like there are Wikipedia page of the linear search and the binary search. You guys want to take a look, okay? But as I mentioned, okay, so do not go too deep in the Wikipedia page, because sometimes those pages become really mathematical. You may not want to have a lot of like mathematical proof in this exam, okay? And let me quickly review what is the linear search. The linear search is just like giving you a sorted array, and you have a number, and you basically just try each interval from the beginning to the end. Okay. Of course, this linear search is very inefficient if the number actually locates at the last interval. Okay. So if I give you a interval 1, 2, 3, 4, give you array 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and if my key is 9.5, that means you cannot find this search. You cannot find this interval until you get the last two numbers, right? So that's going to make it generally very inefficient. And the binary search is like, first it will see. Let me just put the binary search page. It is on page 41 of the slides. I think you guys might want to have a quickly look at page 41. And by the way, the linear search, let's see. The linear search is on page 37, okay? Page 37, okay? So the binary search, different from the linear search, is that it uses this kind of bisection method, okay? So it first divided the whole search domain into two parts. Okay, so for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it divided 1 through 5 to the first part, and 6 to 10 to the second part. And then it first decide which of the two domains the actual key value locates. So still, if our x equals to 9.5, okay, so of course we'll see, okay, it is definitely in the second domain. So we do not even need to check all the 4 or 5 intervals in the first part, okay. And then once we get, okay, it is in this domain, and we then further divide this new search space to 2 and see, okay, which domain is this 9.5 locates, and until we find this specific part 9 to 10 that contains this key values, and that's how this binary search works. Okay, so and I think that's the end of this search area, search algorithms. And finally, we have this application of the search and of this sort and search to table lookup and interpolation. Okay, so I think this part is not that important. Okay, but you guys want to have an idea of how this algorithm works, especially in this example given on page 46 through 49 of this lecture notes. I think as long as you guys can understand this, that should be enough. Okay, let me type in here 249. Okay. Okay. All right. So that's it for the sorting and searching part for this module, and then we continue with the time complexity. Okay. Okay. So the time complexity, I think, first, if I were the one who make the exams, I will probably not give you a lot of questions about to derive what is the asymptotic time complexity, or like what is that big O, what should be something inside that big O. I don't think that will be something occurred in the final exam if I were the well, if I were the one who make the questions, okay. So I think it will be, if I think at this moment it will be not that efficient for you guys to look at the mathematical proof or this kind of derivation at this moment. The most important one at this point, because you only have 2 days before your final exam, is to look at the basic concept. Okay, understand what is time complexity and what is sorting, what is searching, how these algorithm works. Okay, as long as you get this, I think you should be fine in general. Okay, and let me quickly review this one. First part is definition. Okay. Okay, so this definition first, what is time complexity? Okay, I will just put the definition here. Okay, so time complexity. Let me just. Okay, the time complexity is this Tn. Okay, so this Tn, which equals to the runtime of the algorithm in the worst case. Okay, so in general, this time complexity, this one gives you an idea about how efficient your algorithm is. Okay, what is the runtime of your algorithm given the worst case scenario with the number n? Okay, so for example, if we go to the linear search, okay, so corresponding to that, what is the time complexity for that problem given the problem size 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that means it equals to the runtime of the worst case possible. What is the worst case? Okay, it's just what I mentioned just now. Okay, one, the key value will not be found unless you are going to the last 2 numbers. That's actually the worst case scenario. And what is the best case? That means if your key is like 1.5, when you search the first domain between 1 and 2, you should be able to get the answer, right? That's gonna be the best case. The worst case is when your key is 9.5. So this time complexity is defined using the worst case scenario, okay? And of course, this time complexity is a function of the problem size, okay? So if you have 10 numbers, that will be T10, and if you have 10,000 numbers, that will be T10,000, okay? But in each case, it will be the worst case scenario. For example, if you have 10,000 numbers, okay, 10,000 integers from 1 through 10,000, the worst case scenario will be when your key value is 9,999.5. Okay, that will be the worst case. Okay, and also the second definition you guys want to have an idea is this asymptotical time complexity. Okay, complexity. Okay, so let me also write down the definition here. Okay, this asymptotic time complexity is like it's also a increasing function fn. Okay, but this is not exactly the runtime of your algorithm. Okay, but this runtime, but this fn is some sort of the bound of the of this runtime tn. defined in this time complexity. Okay, so how do you look at the piece of code and determine its asymptotic time complexity? So yeah, that's something I will talk about a little bit later, Rick. Okay, then we should be familiar with this big O definition. Okay. Okay. So this big O definition is like defined in this way. It's like an algorithm with asymptotic time complexity Fn is equivalent to that to be the order of O Fn. Okay, so if, for example, if Fn equals to n squared, then you can say, okay, this algorithm is said to be the order of the big O n squared. Okay, so that's just a definition of saying this asymptotic time complexity. Let me change this typo here. Okay, and then once we're done with the definition, then we go to what Rick asked, is like time complexity of some simple algorithms. Okay, so let me first point your guys to the lecture notes 9 to 23. There are 5 examples, okay, given in this section. Okay, so I think in each example in the lecture notes, they go over in very detail how they calculate this asymptotic time complexity and how are you gonna get this big O representation of an algorithm. First, you guys please take a careful look of these 5 examples. Okay, especially example 5. Okay, the example 5 is very important. Okay, and because that one is talking about the complexity of bubble sort. Right, and you guys might have a good idea about how this time complexity of bubble sort is determined by just some sort of analytical derivation. Okay, so understand why bubble sort is big O of n squared. Okay, big O of n squared. You guys need to have an understanding of this. Okay, so the example 5 is on page 18, I think. Okay. Example 5. The example 5 is on page 18. Okay. Okay. All right. And then so in general, Rick, let me try to address your problem in a very general scope. So for given some code, okay, in order to determine the asymptotic time complexity, what you really need to know is how many operations did this algorithm do, right? So for example, if you have some sort of for loop, that means everything in the for loop will be run like n times if your for loop starting from 1 to n. Okay, and then you look at within each for loop, okay, how many operations are there? Okay, and then what you do is you just basically multiply that big N with the number of operations inside this for loop, and you basically get, okay, how many operations are there? And you get the highest order. Okay, so for example, if you get n squared plus n or minus n, you just remove that n. Okay, because as n becomes really large, only n squared will be significant, right? The n will be just ignored. Okay, so that's how, in general, you will be able to determine the time complexity given the algorithm. Okay, so similarly, once you have like multiple loops, okay, first you need to calm down, do not be too nervous, and look at those loops from the very outside one and to the very inside one. Okay, so for example, if you have 2 loops, okay, the first loop running from 1 through n, the second loop running from 1 through m. Okay, so now you know that there will be at least n times m operations of the things inside the very inner loop of this algorithm, right? And you do that level by level, and you multiply the operations from each level, and then you will be able to get some sort of asymptotic time complexity of a algorithm. Remember, you only need to pull out the one that with the highest order, as I mentioned. If you have n cube, n to the 3, okay, in that case you can ignore n squared, okay, because we are talking about asymptotic time complexity, which means when n becomes really, really large, what is the one that is dominant? Okay, so in that case you should be able to have a better idea. But in general, look at page 18, example 5 of this lecture notes, and I think you guys should have a better understanding about how you address these problems in the final exam. Okay, and then finally is estimation of time complexity. Okay, I think if we have some sort of final exam question, if I make a final exam question, I will probably make something from here. Okay, because this is related to linear regression, right? So normally like this, the estimation of time complexity is like estimate the basically it's like run simulations, run the algorithms, and get the plot of Tn with n, with different n. Okay, and then the work of estimation time complexity is using this plot, okay, using those numbers. How would you be able to estimate the order of the time complexity? The order or the parameter. Okay, so I remember there is okay. How would you be able to estimate the order of the algorithm? Time to. Okay, let me just finish typing in. Okay, so Christina, you want me to give an example? Okay, for example, please take a look at the, I think it should be COM homework. Let me see, let me check which homework is that. Okay, take a look at COM homework 2. Okay, so that one is exactly something that use this estimation of time complexity. Okay, so you are given the size of the problem, and you are given the runtime. How would you be able to estimate those little alpha? Okay, that's exactly what this problem is. Okay, Christina, take a look at that homework question, and let me know later if you have any questions. Okay, and then we will be reviewing the last module of this whole class, is the data structure. Okay. Okay, so first, you guys want to have an idea about this data structure called graph. Okay, And there are several definitions in the graph, like node, like edge, like neighbors of the node, path, like path, like cycle, right? Like direct or n-directed graph, and also some like connected graph or something like that. You should have some basic definite idea about the definition in the graph. So in the exam, you might be asked, given a graph, like given this kind of picture in the final exam, and they will probably ask you, what are the nodes, what are the edges, is there any connected graph, is there any, what is the path and from one node to the other node, is there any circle, okay, whether this is a directed or undirected graph, so on and so forth. Okay, so you need to review those kind of definitions. Okay, and you want to be familiar about representation of the graph. Okay, so basically there are two ways of doing that. The first one is adjacency list, and the second one is adjacency array. Okay, so you guys should review that. I think there is a very nice example in the lecture notes. Let me show you where they are. They are from page 21 to 24. Okay, let me just put it here. Okay. This is the first part, basically just some simple definition of a graph. Okay, and then what we do is the depth first search of the graph. Okay, depth first search. Okay, so first you guys need to know what is this DFS. Okay, so this DFS is just like a systematic way of traversing a connected graph related to the pre-order traversal of a tree. Okay, so you guys should also know that tree is just a specific, like, is a special graph basically. Okay, and let me just type in here let me just type in here. Okay, in the DFS, one starts from a given node and visits every neighbor only once. If not able to find unvisited node in the neighbor list, then the DFS backtracks to the previous node and continues the search. Okay, so I think there is a very nice example in the lecture notes. Let me point out that to you guys. An example is available. Oh, let me see. Oh, I'm sorry. So this part is from 21 to 24. Okay, so an example is from here. Okay, and the definition of this graph representation is actually at page 18 and 19. Okay. 18 and 19. Okay, and then you guys should have a better idea about, okay, so what is depth first search given the graph. Okay, and then we talk about the next definition. It is called linked list. Okay. Okay, so you guys first want to have an idea about what is a list, what is a link, and what is a linked list. Okay, so basically the difference between the linked list and some general representation is that this linked list for every node, besides the real value, it also has some sort of pointer that tells you what is the next node of this graph, basically. Okay, so for example, if you look at page 28, okay, you can just take a look at page 28. There is an example of a linked list. Okay, so you can see here for each one, for each node, for example, the first node, it gives you p equals to 3 and next equals to 1. So when you are traveling like in this linked list, you will see, okay, after I'm visiting this node, next one I will visit is a node with this index number 1. Okay, and then you will just be directed to that node, and then you will be directed to the next according to the pointer in that index 1 node. Okay, so that's basically the very important characteristic of a linked list, is that there is a pointer in each node that directs you to the next node of this list. Okay, and then you should what you should know is that you should know how to insert and delete a data item in a linked list. Okay, so there is an example on page 30 and 31 of the lecture notes, and there is also several homework questions. Okay, the last homework, there are several questions in the DAT homework that get you familiar about this link and delete a data item from a linked list. So basically what you do is you are not actually just delete the data itself. You are actually just remove or change the pointers, right? So you are just changing or removing the pointers, not the actual data. Okay, so that's something you should be really familiar with. Okay, and I think the last one I want to talk about is this binary search trees. Okay, so this one definition is given on page 33 of the lecture notes. So this binary search tree is just like a data structure that's used to efficiently organize a large amount of ordered data. Okay, so the key characteristic of this binary search tree is this. The key, let me just type it in here. The characteristic of this of the search tree is that the key of the left child is smaller than the key of the parent and smaller than the key of the right child. Okay, so I think there's also a homework question in the DAT assignment for you guys to take a look at this binary search trees. Okay, and the last point I want to mention in this final review is that you want to have this kind of idea about the time complexity of the linked list and the binary search trees. Okay, so so in general, this binary search trees are binary search trees are in generally more efficient than the linked list. Okay, you guys can take a look at the page 36. Time complexity of linked list binary search trees. Okay, you guys can take a look at page 36 of the slides. Okay, and I think that's the end of the information or message I want to review with you guys about the last two modules. I think in general, as I mentioned, first pay attention to the basic concept. Understand what is the most important concept from each modules. To repeat again, in probability, the most important one, first basic statistics, those basic definition, and the normal distribution. Okay, these are probably the most important one. For sorting and searching, first understand what is a sorting and searching problem, and then pay more attention to bubble sort and street insertion for sorting algorithms. For search algorithms, pay more attention to binary search. Okay, for time complexity, okay, first get an idea about what is the time complexity and asymptotical time complexity, and the most important one is how you will be able to calculate the time complexity of some simple algorithms analytically and estimate the time complexity using some experiment. Okay, and the last module, data structure. First, understand what is a graph. What are the given you a graph, you should be able to identify the different components in this graph, right? And then understand what is a linked list, okay? And how are you be able to change or insert or delete an item from the linked list, okay? So these are, I think, the most important concepts within these 4 modules for you guys to take a look. Okay, I think that's the end of this review session for the last 2 modules. I'll be happy to take a few questions you guys might have about these modules. Otherwise, I will be happy to answer a few previous final exam questions.